Hi everybody, in this video we're going to discuss section 5.3, Introduction to Polynomials. In this video we will define what a polynomial is. We will classify polynomials as either a monomial, a binomial, or a trinomial, or as polynomials with more than three terms, which we'll just call polynomials. And then we will evaluate a polynomial for given values of a variable or for given expressions of a variable. So, before we can describe what a polynomial is, we have to discuss what a monomial is. And a monomial is a term of the form a times x to the nth power, where a is some real number, we call it the coefficient, x is actually our variable, and n is the whole number, and we actually call the whole number the degree of the term. And recall that the set of whole numbers is the set 0, 1, 2, 3, all the way up. So basically, whole numbers are integers that are not negative. So now that we understand what a monomial is, we can discuss what a polynomial is. And it is either a monomial, so monomials are polynomials, or it is the sum or difference of two or more monomials. And there are two other terms we need to discuss. The first one is, what is the degree of a polynomial? Well, the degree of the polynomial is the largest of the degrees of its terms. So you take all of your monomials that comprise your polynomial, find the one with the largest power, that's your degree. And then the leading coefficient is the coefficient associated with that term, i.e. the term of the largest degree. Okay, so we will discuss those in a couple of examples, but before we get on, we actually have to classify some special polynomials. And here's the first one. It's the first one that we defined. It is a monomial. It's a polynomial with one term. So like negative 2x to the fourth is a monomial of degree 4, and 35a to the 10th is a monomial of degree 10. Now, for a binomial, as the name implies, binomial implies two terms. So here we have two terms, 4x squared plus 5x. Now this has degree 2 because the monomial with the largest degree is this one right here, and it has degree 2, and therefore the leading coefficient is 4. Now this is also a binomial, 3a to the 5th plus a to the 6th. This is of degree 6 because the monomial with the highest degree is 6. And here the leading coefficient is 1. Since it's a to the 6 by itself, we'd assume that it's being multiplied by 1. And then finally we have trinomials, which have, you guessed it, three terms. And here they are. In this example, we have x squared plus 6x minus 7. It's the addition and subtraction of three monomials, 1, 2, 3. Yes, that is a monomial. And it is of degree 2 because the monomial with the highest degree is 2. And it has the leading coefficient of 1 because since there is no coefficient, that implies a 1. And then finally we have a cubed minus 8a squared plus 12a. This also is a trinomial. It is a trinomial of degree 3 because it has a monomial whose highest degree is 3, right here. And its leading coefficient is also 1. Now if you have a polynomial with 4 or more terms, we just call it a polynomial. And this brings us to the examples that we need to deal with. And here is our first one. Simplify the following polynomial by combining like terms and then write the polynomial in descending order. So what are like terms? Like terms are basically terms that have the same variable and the same power. So 7x cubed and 2x are not like terms. Even though they have the same variable, this variable is raised to the variable in 7x is raised to the third power. The variable in 7x cubed is raised to the third power, and here this is just raised to the first power. So since they have different exponents, they cannot be like terms. On the other hand, the 5x cubed and the 7x cubed are like terms. As a consequence, they can be combined, and they would be combined to 12 x cubed, and then we can bring the negative 2x down. Now keep in mind we have to write the polynomial in decreasing order, so you want to start with the one with the highest degree, and that of course would be the 12x cubed. And then the next term has lower degree, which would be minus 2x, and that would be our simplified polynomial. Now the degree of the polynomial is going to be, and this actually is a binomial since we have two terms. Now the degree of the polynomial is 3, so the degree is 3. And then again, since we actually have two terms, this is a binomial. Okay, so that takes care of this particular example. Now, in example 2, we actually need to evaluate polynomials. So here we have a polynomial. No, here we have a polynomial. It is negative 4 times y squared times x. This actually is a monomial. And we want to evaluate it when y is equal to 1 and x is equal to negative 2. So what do? Well, we substitute 1 for y and negative 2 for x. And that will give us negative 4 times 1 for y, 1 squared, times negative 2. Well, 1 squared is just 1, so this becomes negative 4 times negative 2, which will be equal to positive 8. So this will be evaluated to positive 8 for this particular case. Now we have another example here, in which is this polynomial, which by the way is a binomial. Its degree happens to be 2, and it has a leading coefficient of 6. Now you want to evaluate this when x is equal to minus 1 and y is equal to minus 2. So once again, oh, that's a mistake there. That should be a minus 1. Well, let's just do this. Okay, so we're basically going to substitute minus 2 for y and minus 1 for x. And now it will give us 6 times minus 2 squared minus 6 times minus 1 times minus 2. Well, minus 2 squared is 4, so that's just 6 times 4. And then minus 1 times minus 2 is just positive 2, so that's going to be minus 6 times 2. 6 times 4 is 24. Minus 6 times 2 is 12. 24 minus 12 is 12, and that would be our answer. So that's the one of the problems that you will see in your homework. Here is another one. Here we need to identify polynomials. Now, if you recall, polynomials are a collection of monomials, and each monomial is going to be a coefficient times x raised to a whole number. In other words, n cannot be a fraction. So with that in mind, let me get back over there. We can look at 5x to the 1/2 and notice we have a fraction here. As a consequence, this is not a polynomial. Because a polynomial cannot have fraction exponents. Okay, let's take a look at the next one. This one is a polynomial. This is a whole number, and this is a whole number. So this is a polynomial. Let's take a look at C. C, once again, is not a polynomial because this exponent is a fraction. So this is not a polynomial. And then next we have 5x cubed times 4x to the minus 1 power. Now look at this. This is a negative integer. Negative integers are not whole numbers. So this also is not a polynomial. For it to be a polynomial, all the exponents have to be 0 or higher. And then finally, this is a polynomial. Notice that 1 could be rewritten as x to the 0, which is a whole number, so that is fine. And we have an integer power here, integer power there. This is to the first power. This is to the 0th power. Once again, 0 is a whole number. So this is a polynomial. So that is the second type of problem that you will actually see in your homework. The third type is this. To identify the type, degree, and the leading coefficient of polynomials. So here we want to classify the polynomials as either monomial, binomial, or trinomial. Now remember, monomial has one term, binomials have two terms, and trinomials have three terms. Okay, so take a look at this one. This one has two terms. Here's term 1, here's term 2. So this is a binomial. The term with the highest exponent next to the variable is this term right here. The exponent is 2, so this is of degree 2. And the leading coefficient, we're just going to call that LC. Well, the leading coefficient in that particular term is 5, so the leading coefficient is 5. Okay, let's take a look at B. Okay, here, once again, we have two terms. It's a binomial. The term with the highest exponent is right here. The highest exponent associated with the variable is right here, which is 6, so the degree is 6. And the leading coefficient is the coefficient in that term, which would be 5. Okay, for C, now we have three terms. 1, 2, 1, 2, 3. So this is a trinomial. Notice degree here. Notice the degree of the highest the degree associated with the degree of the highest monomial is 2, so its degree is equal to 2. And the leading coefficient is the coefficient in that particular term, which is a 6. And then our last one for this particular example is this one. This is also a trinomial. Three terms, 1, 2, 3. Now here, the monomial with the highest degree is this one right here, and that has a degree of 5, so the degree of this trinomial is 5. And the leading coefficient is the coefficient in that term, which is 2, so the leading coefficient happens to be 2. And there we go, that's it. And now we have our last example in this particular lesson, and it is this. Once again, we need to evaluate a polynomial. However, in this particular case, we are not going to evaluate it with a value. We are going to evaluate it with a given expression. And here is the expression. So we're going to do this the exact same way we did this in the very last lesson of chapter 4. We have this function. We are going to substitute whatever's in this argument with x. So here the argument is 3a minus 5. That's what we're going to, and we're going to replace that with x. So that will give us that g to the 3a minus 5 is going to be equal to negative 5 times replacing this quantity with x, 3a minus 5, and notice how I have it enclosed in parentheses, plus 13. Now we can use the distributive property. I will have negative 5 times 3a, which is going to be negative 15a. Negative 5 times negative 5 is positive 25. And then we have positive 13. Now notice I have two like terms. I have a like term here and a like term there. Both have the same variable. Well, no variable at all, so it's kind of like the same variable in power. In this case, it would be, you could interpret it as being a to the 0th. But nonetheless, they can be combined, and that will give us negative 15a plus 25 plus 13 is 38. And that would be our answer. Okay, so that pretty much is the lecture portion for this particular video. Give me a second, and then I will get Hawks up and running, and we'll do a couple of problems. Okay, so here I have Hawks up and running, and notice that we have to evaluate 2y x squared when y is equal to 4 and x is equal to negative 2. So we just go ahead and do the substitutions. We're going to have 2 times y, which is 4, times negative 2, the entire thing squared. All right, well, we should take care of this, the exponent first. And negative 2 squared is just positive 4, so that will give us 2 times 4 times 4. 2 times 4 is 8 times 4. 8 times 4 is 32. And that should be our answer. There we go. Okay, let's move on to the next problem. That is pretty much the exact same type of problem, so we're going to move on from there, as is that, although it's a little more involved. Actually, let's go ahead and do it since it is a little more involved. So here we have 6xy cubed plus xy minus 4y, and that should be y cubed. And we are going to let x be equal to negative 4 and y equal to negative 1. All right, so that's going to be 6 times negative 4 times negative 1 cubed plus negative 4 times negative 1 minus 4 times negative 1. Okay. Well, the first thing we want to do is deal with the exponent here in this particular term. And negative 1 cubed is basically negative 1 times negative 1 times negative 1, which, you guessed it, is negative 1. So we can write this as 6 times negative 4 times negative 1. All right, now here we have negative 4 times negative 1. Okay, that will be a positive 4. And now here we have minus 4 times negative 1. That's pretty much minus a negative 4. And now we can evaluate this some more. 6 times negative 4 is negative 24 times negative 1. And here, and then plus 4. And then minus a negative 4 is just like plus 4 again. And now negative 24 minus 1 is negative 24 times negative 1 is going to be positive 24 plus 4 plus 4, and positive 24 plus 4 is 28 plus 4 again is 32. This should be 32. Okay. Now we are moved to the type of problems where we need to decide if this is a polynomial or not. Now notice here we have a fraction in the exponent. Since there's a fraction in the exponent, this is not a polynomial. Okay, now here we have whole numbers for exponents. We have an implied 1 here and a 2 there, so this is a polynomial. And this, of course, is not a polynomial because we have a fraction in the exponent. Okay, so now we're going to move on to some different problems. So we're going to skip that. And now we are going to classify polynomials. So in this particular one, we have two terms, 5x squared plus 3x. So since there are two terms, this is a binomial. Now for the second part, notice we need to find the degree and the leading coefficient. Well, this monomial has a degree of 1. This monomial has, or this term has a degree of 2. So this, since this is the term of highest degree, that is the degree of the polynomial. Okay, and now the coefficient associated with this is 5, so the leading coefficient is 5. And now let's take a look at this one. Here we have 1, 2, 3 terms. As a consequence, this is a trinomial. Now notice here that this term has degree 1, this term has degree 0, this term has degree 2. So this is the term with the highest degree, and the degree of this term is 2, so we'll put a 2 here. And the coefficient in this term is a 6, so the leading coefficient is going to be 6. Okay, so that's how the rest of those work. In this case, we have the function p, which is a function of x, which is defined as 5 times x minus 3. Now we want to evaluate this function at the expression a plus 5. And that means that wherever we see an x, we're going to place it with the quantity a plus 5. So this will be 5 times the quantity a plus 5 minus 3. Distributing here, we'll have 5 times a plus 25 minus 3, which will be equal to 5 times a plus 22. And that should be our answer. And there it is. And that pretty much covers this lesson. If you have any questions, please feel free to call me. Otherwise, this is Bob Boyle, signing off.